Okay, boys and girls, today's lesson is 8.6. The essential question for today is how do you use a formula to calculate the area of a parallelogram? Now remember yesterday we did rectangles and we used the formula A equals L times W. L being length, width being W. Today it's really not going to be that far away from this, but notice the question did ask for formula of a parallelogram. Now rectangles can be a parallelogram, but we're going to focus on the type that's a little bit more stereotypical with the slanted sides like this. Alright, now it's not that far away from the rectangle. I've always kind of looked at the parallelogram myself as if like it's a rectangle that some really strong dude like myself is kind of pushing over to the side, so it's kind of shifting down. But you can visualize that this could have and would have been a rectangle at one point. Now what you want to do is you want to kind of be prepared to visually manipulate or change the parallelogram to see how we can calculate this area, because the weird part is that you have these angles on here. Let me do that in another color. You have these angles in here. The rectangle is easy because everything was perfect squares. So is there a way that we can turn this into having perfect squares? Hopefully you're starting to see what I see, which is this little triangle that comes on here. So you could actually take one part of the parallelogram, essentially cut it off and put it on right here, and it would build a rectangle that's the same exact area. So if you had a piece of paper, you could actually cut this thing off right here, take it over and tape it right on this line, and it's going to build one rectangle that has the same exact area, kind of like the study link where we cut the different cubes apart, glued them back together. Okay, so now looking at what you see here, let me get you a clean one. Alright, we're going to look at A equals B times H. You should remember that from yesterday, and that is area equals base times height. We want to count across the base on this. That's 1, 2, 3, 4, 5, 6 across for our substitution. And our height on this one is 1, 2, 3. Now the reason this works, guys, is once again, if you were to take this off right here, I'm going to shade this part in, and you put it over here, you would see that you now have a perfect, I'm going to highlight all this in blue, a perfect 3 tall, 6 across rectangle. So with the parallelograms, the A equals base times height, you don't have to worry about those angles. Once again, if you can just find that horizontal or side-to-side measurement across the bottom and then that vertical, that's where the word perpendicular comes in from the vocabulary, is you need those two different measurements. You need the vertical and you need the horizontal. Alright, so we can finish this one off. This would be 18 units squared. Now some parallelograms you'll see the flat side over here, and then it kind of slants this way. We got another flat side, and it slants this way. Don't get alarmed by this, okay? You can just kind of in your brain picture this rotating back around, and that this would be the bottom side representing the base. So I'm going to count this 1, 2, 3, 4. Looks like 4.5. Area equals 4.5 for my base. And the height on this one would be 1, 2, 3, 4, 5 blocks. 4.5 by 5. Okay, so we would multiply this through. 5 times 4 is 20. 2 halves, that's 22. 22.5. 22.5. Hopefully somebody realized the step in my formula that I forgot to do, because I would yell at you guys for doing it, but I forgot to do it myself. And that is my formula, A equals B times H. That should have come down here first. A equals B times H. Okay guys, take a look at the journal pages that we have today on 236, 237, and I think there might be one more, 238. Yeah, 3 journal pages today. So make sure you're ready for any questions, and good luck.